So, other examples would be that you're probably familiar with things like a lot of viruses will self-assemble if you give them, if you have all the components, they'll form
Yeah,
fairly
yeah.
complex structures. Strictly speaking, that does not require energy as long as the proteins are above some minimum concentration.
They're just gonna all kind of snap into place.
Yeah, exactly. It's a little eerie too. If
Right.
you now have the capacity to watch it, maybe not at the quite at the level of the individual things, but you can see filaments coming out apparently out of nothing. If you have a mixture of actin and it's above some concentration, you start your movie and it's fluorescent. It's like there's nothing, and then whoop, here comes a filament. Same for
Yeah.
microtubule. Um, Self-organization is a little more complicated. It does require energy by definition, and it typically refers to higher level processes. So if you have mixtures of, say, actin filaments and myosin, or microtubules and various microtubule binding proteins, they can self-organize into more complex structures. And this is an example of something I think you've covered before in your podcast. But basically, there are emergent behaviors that characterize self-organization. So put really simply, the output of a mixture of things is not predictable based on the individual components. You have these sometimes even more eerie and more remarkable things forming as a result of self-organization.